In poker, the probability of getting dealt a full house is 0.0014. What is the probability that you will get one full house in 7 hands? So first of all, let's make sure that this would result in a binomial probability distribution before we use our formula for the binomial probability distribution. Are there a fixed number of trials? That's the first criteria. And we're talking about 7 hands, meaning we're going to play poker 7 rounds. So there's a fixed number of trials. Each trial is independent, possibly technically no here, because once you've dealt some cards, that might change the probabilities of getting dealt a full house. However, we can treat it as independent because the probabilities won't change so much. So let's treat it as independent here. Are there one of 2 possible outcomes? Meaning, can we call something a success and something else a failure? So let's call getting a full house a success and not getting a full house a failure. The last thing we have to consider is, do the probabilities for a success stay the same? And of course, in this case, they will slightly change as we deal more cards, but not enough to be significant. So let's consider the probabilities staying the same, being 0.0014, and that'll allow us to use the formula for the probability of a binomial distribution. So the question is, what is the probability you will get one full house in 7 hands? So we can use our formula and calculate the probability of 1. Since there are 7 trials, this would equal 7 factorial divided by 6 factorial times 1 factorial. Now, of course, the 6 comes from the fact that we're taking 7 minus 1 factorial. Now we multiply this times the probability of a success, which in this case is 0.0014, and we take that to the x power, or the number of successes. So here we're talking about 1 success, times the probability of a failure, which is 1 minus 0.0014, or 0.9986, to the 7 minus 1 power, or 6. So plugging all this into the calculator, or rather, let me write this out. This would equal 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 7 factorial. Times, on the bottom, divided by 6 times 1, oh boy, 6 times 5, let me fix this, 6 times 5, times 4, times 3, times 2, times 1, that's what we get from 6 factorial, but we also need to multiply times 1 factorial, which will be times 1. Of course, the 1s don't change anything, these guys, but we still include them just for completeness. Now, notice several of these factors will cancel off. So let me cancel these off before we go on in our formula. That is, 6s will cancel off, 5s, the 4s. The 3s will cancel off, 2s, the 1s. Of course, we're left with a 1 in the denominator and a 7 on top. Now, plugging the rest of our decimals, or our probabilities, into our calculator, we'll get 0.0014 times, now 0.9986 to the 6th power is 0.9916. So now we just multiply everything together. That is, multiply the 7, that is, the 0.0014, and the 0.9916. Multiply it all together, that gets us 0.0098.